Here's a Riemann problem where we have to estimate the area between the curve x equals 7 over y cubed and the y-axis using left-hand, right-hand midpoint, and trapezoid approximations. And we're doing this on the interval 1 to 8 with 7 subintervals. So here's a graph of the function, and here's a table of the y values and all those function values. And so first we'll find delta x using the formula b minus a over n, where b and a are the endpoints 8 and 1, and n is the number of subintervals, which we have 7. So doing this, we get delta x is equal to 1, which is pretty convenient because 1 is going to be the width of our rectangles. Sometimes when you're doing a Riemann approximation with respect to the y-axis, it can be a little confusing as to which y value to use for left and right hand rules respectively. So here's a stick figure with left and right arms, and he's looking up at the x-axis right now. So if we rotate the stick figure to be looking up at the y-axis, we can see that the left hand is the greater y value and the right hand is the lower y value. So for our left-hand rule, we'll be looking at the greater y value and the function value for the greater y value. And then here's a little graphic that will move to the bottom of the slide right here. And so we'll start with the left-hand approximation, and we'll be using delta x is 1, keep in mind. So 1 times, and then our greater y value, we'll start with 2 because that's the bigger one, and that's the x of 2 is 7/8. So we do this so on until we add all of them up, and we have 7 of these rectangles that we created, and that sums up to 1.366 for our left-hand approximation. For right hand, we'll be using the lower y value, and so we have 1 times 7 plus 1 times 7/8, and so on, and that sums up to 8.352. Next is our midpoint approximation, and to do midpoint, we should see that the midpoint between 1 and 2 is 1.5, between 2 and 3 is 2.5, and so on. And so here's a table of all these midpoints to make it easier for us to approximate using the midpoint rule. And then our delta x is still 1. And so to do the midpoint approximation, we'll have delta x times the midpoint function value, and we add all these up, and we get 2.846. Lastly is the trapezoid approximation, and here's a formula where we have delta x times the average between the two function values. So 1/2 times x of n plus x of n plus delta x, and delta x is 1. So I left out the delta x here because it's just 1 and it won't change these, but we can sum the averages, so the average of 7 and 7/8 plus the average of 7/8 and 7/27, and so on, and we sum all of these and we get 4.859 as our final answer for the trapezoid approximation.